Hello. This is my first look into computer science. My name is Kevin Honey, and I'm in the CS102 class. So today I'll be talking about my course overview. The two topics that stood out to me were common computer architecture, ethical and bias in computer science, and topic I brought to the table today was augmented reality. And finally, I'll just give my final takeaways. So throughout this course, I gained a way deeper understanding computer science. First we talked about fundamentals, what computer science is. I learned about how it encompasses hardware, software, algorithms, data management. We talked about computer architecture and components. Which helped me understand how computers work at a fundamental level. The topic of algorithms was eye-opening. Showing me how to solve problems efficiently, step by step. Programming languages highlighted how different languages suit different tasks and applications. I also gained insight into data structures. I learned how they organize and store data efficiently. Networking expanded my perspective, right? So it showed me how we connect and communicate on a global scale. Machine learning was particularly interesting to me. It was nice to see like AI and how computers can learn from data. And then finally, we talked about ethics, which I'll talk about a little bit more here in a little bit. But this just emphasized the responsibility we have as creators, right? Overall, this course broadened my understanding and definitely sparked my interest in many pieces of this computer science world. So the one topic I brought to the table, that stood out to me about this course was computer architecture. So computer fundamentals, right? The most basic level. A computer is a machine that can receive, process, store, and output data. The core components of any computer have to include a CPU, memory, storage, operating system, and some way to interact with the computer, input, output devices. So first talk about the CPU, right? So this little guy here. So the CPU is responsible for executing instructions, performing calculations, managing data. It really is the brain of the operation. So it gets its information from memory, right? And decodes it and executes the instructions provided by the memory. So this guy here. So talking about memory, right? So normally we have two types of memory. We have our mass memory, and we have our main memory and our secondary storage, right? So our main memory, more commonly known as RAM, this guy here. So it's pretty fast, right? It's pretty fast memory, accessing data like really quickly, but because of that, it's also volatile, right? Anytime we turn a computer off, it wipes that data. So for that reason, we only store information on the RAM that our CPU is actively accessing. So we talked about mass storage. Mass storage, is referred to normally as long-term storage. So this is where data is saved when the computer is even turned, like when the computer's turned off, right? So common examples would be hard drives, so like this guy here, SSDs, and more commonly now, cloud storage. So they provide a large space for storage, and because of that, for one, they're less volatile, but because of that, also they're quite a bit slower than RAM. But they hold, operating systems, applications, and all of our personal data files, and all that. So the next thing in computer architecture is the operating system, the OS. So this is a crucial component. So this is how we interact with the computer. It provides us an interface. It allows us, to interact with the computer and tell it what to do. It controls the CPU, manages memory allocation, handles input and output operations. So it's a pretty important part. To summarize, computer architecture is complex, but it's pretty organized. So it relies on the components we talked about, CPU, memory, storage, and the OS to function. So this is all based off of, we talked about this in class, the von Neumann architecture, right? So it's a concept for us to use a single memory for both data and instruction. So this is kind of what we stay on today with all of our computing systems. So understanding the roles of memory type, like RAM, mass storage, as well as binary system, really helped me understand how computers process information, and it's essential for us computer scientists. So the next topic I'll kind of be talking about really interests me was ethical issues in computer science. I didn't think this was a big deal, but after researching a little bit, it has a lot of stuff going on with it. So we focused on legal and ethical considerations and the ACM code of conduct or code of ethics, and also we touched on bias in AI. So as technology continues to evolve, it's essential for us to address these ethical challenges, right? So first, legal and ethical issues in a computer in computer science encompasses a wide range of concerns. We hear all the time about privacy, data protection, intellectual property, and cybersecurity. So with this new rise of data-driven technologies, social media platforms, mobile apps, personal data is it's all being collected, stored, and used in ways that can sometimes raise an eyebrow. So how do we balance innovation with privacy rights? How can we ensure security of user data? These are just kind of a couple examples of some ethical dilemmas that we face in this day and age. So one way we guide ethical behaviors in computer science is through the ACM code of ethics. So this, basically is a guideline to help us navigate ethical challenges. It, focuses on honesty, fairness, respect for privacy, and overall the responsibility to consider the broader societal impact of technology. So another pressing issue is bias in AI. So AI is becoming integrated into everything. Soon, who knows, it could be integrated into criminal justice, healthcare. But it's crucial for us to recognize AI systems can be inherently biased. So, for instance, facial recognition systems have been shown to have higher error rates for people with darker skin tones. Overall, just addressing these bias, and ensuring diversity and training data and developing transparent algorithms, just helps us mitigate that. So, in conclusion, we all have a responsibility. Right, we all have a responsibility to look out for, our what we do on society. So what I kind of brought up was augmented reality. So we see this today now, smartphones, special glasses. I put this Google Lens piece on here because it's it's a new innovation. So we just really want to bring up the ethical concerns. It does collect personal data, can have privacy issues, and there's also a risk that people could become too absorbed in digital worlds. So in conclusion, my understanding of computer science when I came in initially, it's evolved significantly throughout this course. I had basic understanding of what computers do, and I have a way deeper appreciation for how complex they are. Systems like architecture, algorithms, and machine learning, like seeing how they all work together in ethical challenges, it's really opened my eye to what's in store for me in the coming future. But overall, it's our responsibility to ensure technology is developed and used for the right way. And so, yeah, that's my basic overview of what I took away from this orientation class. It was really great. Thanks again.